Any questions or comments on fault modeling? Now, as long as we are talking about fault modeling, let me mention, let us come back to, so this is transistor level, and let me also mention about bridging faults. Now, you can model bridging faults at the transistor level. You can model bridging faults at the gate level also. Now, before people had started working on transistor level faults, people modeled bridging faults at gate level. Let us say that you don't know anything about transistors. You only know about the gates. Then what can a bridging fault do? So assumptions are, the model is two bridged nodes will cause the output at both to be either okay, what happens if you connect a 0 and a 1? Now, do you think, now some of you have done work with transistor level circuit design, right? So which is more powerful? I guess computer scientists are not supposed to know the answer to this question, but electrical engineers perhaps might have thought about this. So if there's a fight between a 0 and a 1, which one do you think will win?
1.
0, why?
Because it's going to the ground, so I mean, anyway, it's shorted. I mean, if you have a resistance in between, then it's potential. So
yeah,
it's probably going to be 1. If it's shorted, it's.
But actually, it's, unless you know about transistor dimensions, you probably cannot really answer this question, because it will be a voltage divider arrangement. So depending on which path has less resistance, right? And unless you know the transistor dimensions, and actually there are some things that are done routinely to size transistors. But we don't need, but let's assume we know nothing about that. So all we know is that two nodes are bridged, they get connected. And so what could possibly happen? So people thought about this. They could be either ANDed, and in this case it is called an AND bridge. And in this case, basically, you have 0 dominates. And other possibility is that they could be ORed. And that is referred to as OR bridging. And in this case, 1 dominates. So, here's an example. Let us have a little circuit here. here we have a circuit with two outputs, and here we have normally this output equal to x1 plus x2, and this output is normally equal to x2 plus x3. Now what happens if they are bridged? And let's assume that this is AND bridging. Then the faulty output or faulty outputs they are, it is going to be the AND of the two. So would be okay, let me come up with a more interesting, let me change the example. Let me make it a little bit more interesting. Let me have a short between these two lines. Okay, this is more interesting. So basically x1 and x2, and let's assume this is AND bridging. So what would happen? X1 and X2 are replaced by X1 ANDed with X2, right? And we can say that in that case, faulty value of Z1 and faulty value of Z2 is going to be, now this X1 is going to be replaced by X1, X2. Oh, and X2 is replaced by X1, X2, so that is going to be X1, X2, and Z2, this X2 is replaced by X1, X2 plus X3. So this is how the faulty function would look like. So notice, since these two are connected, so both of them, they have this, they will get replaced with the same value. So if a 0 dominates, then this effectively that is AND bridging, because in an AND function, if any single input is 0, the output is 0, right? Now let us consider another example of bridging faults. Sometimes it is possible okay, let me ask this question. Here you have normally the output would be, this is 1, so this is 0, and this is 0, so this would be 1. This is what it would be normally. But if, let us assume that here we have AND bridging, then what would happen? Okay, let me make it a little bit more interesting. Okay, let's consider this here. And that would be 1 and 0. Okay. So do you think they are both going to be replaced by 0? What will happen that if we replace both of them by 0, this one becomes a 0, and this 0 then becomes a 1, and it will keep on going. And so there are two possibilities. It might oscillate. Basically, changes may go around. Now notice that this is an example of feedback bridging. Where an output is connected to an input. So it may oscillate or settle at an intermediate value. Depending on the delays involved, if you have a feedback bridging, it can the changes can go around, or it might settle at some a value that is somewhere between 0 and 1. Any questions or comments?
What could be the value between 0 and 1?
Between 0 and 1? So remember, so there's some 1. Okay, 0 is represented by 0 volts, right? And 1 is represented by, let's say, what is the current supply voltage that people are using? Let's take, I don't know, 1.5 volts, 2 volts. At one time it used to be 5 volts, back when I was a student. So it was easy to remember. Supply voltage 5 volts, but they have kept decreasing it because in order to reduce power consumption, because the chips are big, and if they keep 5 volts, the chip will burn. So in order to reduce power consumption, they have to reduce the supply voltage, and the supply voltage has come down to quite a bit. So 1 is represented by, let me assume it's 1.5 volts. There is a lower limit to supply voltage, which has to do with the characteristics of the transistors. So somewhere between 0 and 1 would be, I don't know, maybe 0.7 volts. Now, will it look like a 1 or will it look like a 0?
1.
We don't know. It depends on the characteristics of the electronics involved. So you can analyze the circuit and do a little, now what do we call that? A little DC analysis. Find out what the voltage would be. And so generally gates are designed to react to inputs. So if a gate, so there is some range, there's some noise margin around 1.5 volts. And there's some noise margin here. So from 0 to, I don't know, some voltage level, it will be recognized as a 0. Some voltage range here will be recognized as 1, but there is some voltage range here which would be unclear. So basically whatever gate, whatever input it goes